Hello. In first part of our Solana ecosystem exploring, we talk about mem slots and how we can deploy tokens by SPL token and our actual front-end TypeScript with libraries help. And today we're gonna, let me show you first this demo that we checked in previous video. Some token I explained in previous video, when we can deploy it by just some function that is inside our code. Actually, we deploy like this in a TypeScript way. But how we can actually deploy our tokens and write smart contracts in Rust on Solana? How it's gonna work? How you can do this and what instruments you can use, like what tools? Here in the bottom we have this Solana slot machine, some another one, yeah, but not as big as this. It's just another example that I added here, and with this example we're gonna have actual spin slot. If we click on spin, we have spinning and we have our approval. Here we need to approve every spin, and like imagine this like some approve to do spin. But in our case it's just a counter with a result and some mock data that show that we win. You see that we win or lose. For example, when I spin again, I'm gonna see two similar symbols here. I don't know what symbols exactly, but it should be two similar symbols. Yeah, in my case it's crown. So you see you can do it like this. I just updated page, and every time you're gonna get some, in my case now jackpot, even 777 jackpot. Yeah, anyway, it's just mock data for jackpots and not jackpots. Our main contract just counter our number of spins, let's be honest. But it's a good smart contract to start with, to check how it's work, how you can deploy it, and actually to check code of Rust and Anchor and how it's gonna work correctly. All code you can find in description. Here in my open source code you can take front-end part and simple slot. Simple slot part, it's actually our part where we're gonna work with our actual smart contract in Rust. And if we check simple slot here, it's just a cargo program, but usually it's Anchor. In our case, imagine that Anchor is just in EVM. It's hard hat or Foundry or something else, but in Solana have Anchor instead of this. Yeah, you can check here how you can set up front end. It's at the bottom, and how you can set up and deploy smart contract. I already write all instructions for you, but if something gonna happen, if you're gonna have some errors or don't understand how to do this, but it should work correctly because I did it myself, not once. For VSL or Ubuntu we need to do this library here. They have Anchor on Windows, but it's works strange. I recommend you use VSL anyway, because on Windows some libraries are broken, some compatibility problems, etc, etc. It's usually what. So in our case we're gonna use VSL. I already do this. You can write sudo apt install some dependencies that we need to actually do deploy. We install Solana if you don't have Solana still, and install Anchor to our cargo install. Next we can build this Anchor. Actually first we can create Anchor project with this Anchor build. Yeah, just Anchor init. Nothing hard. Anchor init, test template Rust. In my case I used the Rust. I recommend you use this. But you will ask, what's Solana Playground? Is it like remix or something? Yeah, you're right, it's like a remix for Solidity, but we're gonna deploy our code in actually in VS Code, so no worries. We're not gonna use this SolPG, but if you want to use the SolPG, it's easy. Like I already deployed Rust and some another project. Let me delete this project and create again to show you. If you want to create a project like this, you can click new project. There is choose Anchor Rust, I recommend, because native Rust have a lot of code, you see in the background. Native Rust use Borch to like the deserialize numbers. Solana program with this all this stuff that you need to set up by yourself. See, of course, I don't know what it is on Python, but I'm not sure about its compatibility for now. So for us, we take Anchor, we write Koma, and I recommend use Rust for now, because first Solana is smart contracts is on Rust, so it will be more good if you're gonna understand Rust there. And in Anchor, you see it's a lot of smaller amount of code, and here we just use AnchorLang to import our AnchorLang features that we can use, declare, and blah blah blah. I will explain in my VS Code this later. But what I want to show you that you can build this code and then deploy it after build successful. And for deploy, I'm not sure that I'm gonna have enough Sol, because deploy is a bit costable here. Yeah, you don't have enough Sol to complete deployment. For airdrop, I guess I don't get enough requests, yeah. But it's still some balance changes. You see, it's just drained my balance fully. I guess it's try to deploy, no? Or what the fuck happened? Just error, but I see that my balances goes away. Yeah, you see, it's not like remix, it's a bit more strange playground, but pay attention that it's beta Sol PG, so I don't have a right to like say that it's trash, because it's already a bit of good for deployment. Instruction index reason sufficient funds. Yeah, it's not deployed, and my funds is getting back to me, because how you know, in Solana we don't pay once for our smart contract deploy. We pay like rent. You saw that it's like drained, not at once, but it's drained. It's just drained our rent like time to time. And in our case, it's try to do all rent drained at once. And I don't have enough for this rent. But when you pay this rent, you're gonna get this deploy forever. So don't think that rent is infinitive, like for some in real world apartments and other stuff. But it's just called like this in Solana. So next, Sol PG, you can use it, but we're gonna use it in more developer stuff way. Not beta Sol PG, not remix. We're gonna go just inside our PDA reductor. So let's go. Yeah, for deploy it's like this. I show you deploy. If you have some questions, you can write in comment on or in direct message to me. I will try to help you. But okay, let's go to our actual code. We close all this trash for front end. I just recorded previous video before. I'm a bit tired after this, but still, we need to do stuff. And if we check, it's after Anchor init project, you're gonna get this structure already. All the structure gonna be like this. Yeah, all the structure is gonna be like this. Just talk too much. Package.json is created for us. We don't need to change there anything for our smart contract. All this stuff it's after generated. Only thing that I want you to change here, it's in Anchor toml. Pay attention. We have this wallet, and you need to add your wallet route here, but I guess by default it's gonna be already right for you. For me, I need to change this to my actual VSL environment Solana ID for my wallet. And in simple slot in programs Devnet, for deploy we need to add our current deployment. Our current deployment we can get when we do Anchor deploy. Imagine that we do deploy here in our Anchor deploy. No, not deploy, sorry, our build. I mean build, not deploy. Not in workspace. Yeah, I need to change to simple slot. And Anchor build. For me, it's already should be cached build, but for you at first you don't gonna have all this target stuff here. Is profile optimized target, yeah. unoptimized, and simple slot target, simple slot. We get some stuff here. For first build, you're not gonna have this EDL simple slot. Pay attention, because this interface design language or something like this, EDL, interface definition language. Yeah, sorry, a bit different. In interface definition language, just imagine it's like our JSON interface for Ethereum EVM wallets, for EVM stuff. Like for EVM we have ABI, application binary interface. For Solana we have EDL, interface definition language. Yeah. And when you do first Anchor build, you should have noticed for 4 seconds, but you need to wait a bit longer for this build, and you're gonna get this EDL with some address. For me address like this, but for you it's gonna be different, because I explained in the first video, and here I want to say it again, that for Solana, when we create smart contracts, we create a different address that it's separate from our main address. And actually this address gonna be really useful. You need to take it from here, your address, add it to your Anchor2ML here. You see, for me it's the same. And for your libRC in this road in program simple slot.src, it's our actual smart contract. And we're gonna now check what the phase happening there. Here we're not gonna change anything. At least for me, we don't need so for my smart contract. For migrations, we also don't need to change it. It's already set up fully. Yeah, for us, interesting this EDL that's gonna be generated here. And for us, I guess it's all what we need to change. I already showed it to you. And now let's finally check our smart contract. It's small one and easy. Let's actually try to find the smart contract. If we check my account, I should see the smart contract that I deployed somewhere here. Something like this. Is it ready? Check, is it ready? Yeah, it's the same one. Yeah. So you see in this contract it's already some compute unit price. It's when I do spins. So let me actually try do spin again. And we should see now that our spin is correct now. And it should be our smart contract. Yes, spin is done, and now by this address we should have see, yeah, 30 seconds ago it's same address that we're gonna use owner BFP upgradable loader. In our case, owner, you see, it's BFP. Last deploy slot security text. We don't have security text because we don't need. Program is not verified. It's like in EVM. You can verify it, but in our case we don't need this because it's demo. And imagine it's like just a smart contract for this, like just deployed smart contract. But you see, even before we deploy it, we already have this address from our deploy build. And to deploy it, we actually need to take this address from EDL, add this to our smart contract. Like, you understand, yeah? We just manually say it to our smart contract where we need to deploy it. Like, they should be similar with simple slot and other things, because it's Solana way how it's work. So next we have this smart contract with Solana. Yeah, so 5 Sol here. It's because I added Sol in testnet faucet, but it's actually never mind. Now let's finally check our smart contract, how it work. Yeah, you see here we can't check actually constant, even we only have this struct with slot state. Pay attention. If we try rough, we're gonna see all this metadata, instructions, accounts and types. How you're gonna see next is gonna be a bit similar structure with our smart contract. For rat here, for rough. Yeah, just remember this structure and check now our smart contract in Rust. Now we add this EID here. We use AnchorLang for use features from Lang library here. And finally we create program. In our case, imagine it's like system program in Rust in Solana. But in our case, it's public module simple slot. Use super, it's how you know we can use it not everywhere in Rust, it's just Rust syntax. And now we have public function spin that actually happen when we do spin with context and result. Context and result is going from our answer length, I guess. Yeah, from answer context. Here we just get some, imagine it like a TypeScript, but in answer way. We have this result. The result can get only true or false, I guess. Results types that represent either success or failure, yeah. Okay or error, like true or false. Yeah, no, I don't need this. But yeah, you see, in our case, result is just true or false. It's mean like at first it's like win or false, like you lose or you win. But in our case, it's every time we gonna add one, so we win every time. This contract can just be upgradable to have function to actually have jackpot or have lose state. You can actually do this and send PR to my repository. I will be glad to check this, and it will be good for educational purposes. But let's continue. For inside spin public function we have slot that have this mutable variable point on contact account slot. It means it's mutable slot that we can change a number for this slot. And how you understand a slot, it's just a number that's gonna add by itself every spin. For example, for us it's already 28 slot 28, like it's added 28 times by itself. And yeah, you see we don't have randomness here. Imagine it like to do. Okay, shouldn't give randomness, we need 1. And for us it's just some counter with slot result that's gonna be wrapped add by 1. Yeah, you see here we even use wrapping add to actually compute self-pierce hash of the boundary type. Yeah, it's to not have problems with some computes here. So we can wrap in add by this, we can change it to add more, but we need to counter spins one by one for at least logic like this. Next we have a really important public structure, public struct. You see we first derive account, like imagine that we get this account. Remember I already told you about account, and we need to derive it to get actually account that we're gonna create when we create the smart contract, when we deploy it. We're gonna create account that's gonna be owned to this smart contract like middleware. We're not gonna be owner like our main wallet. We're gonna be owner, but like through middleware anyway. So this middleware needed in Solana for responsibility and security issues and for key concepts of Solana. And in every deploy we create some account that's gonna be linked to our smart contract. And for this account init if needed, it's used if we don't have actual contract here. I think it's like this address already by build. But for us we have some declare ID. But in any case we need this fallback so it can create it itself if we're gonna deploy it. Pair equals user, like user pay for this by his gas. We can change it to some system pay for gas instead of user. But in our case user lost Solana every time he do transaction. Space 8 by 8 plus 8, it's mean UNT. Seeds mean deterministic account for our PDA. It's program derived account. If you check in the documentation of Solana, program derived address, not account, program derived address. It's mean address that account address points to the account location on the blockchain. Yeah, it's like account to check to show where on the blockchain is our actual smart contract. Yeah, in Solana it's a bit pain in the ass. Many account addresses are the public key of a key pair, in which case the corresponding private key is used to sign transaction on the account. It means we don't need approval for a sign. We just can sign it by automatic seeds. And for bump, it's how I checked, it's for last byte of PDA we can add bump to add it automatically. Something like this, like to not broke last byte of our PDA account, PDA address, not account, private derivative address. I just talked too much. I need to rest after first video, but I still talk in another one. And now public slot, account info slot state, we just like in public slot we assigned it to this account that's gonna be created here. It's actually also natural length feature. And this slot state is gonna be slot state, it's a struct here for account that we create. We have user that's signer of this account, and user it's my main wallet in this case, or a wallet of another people who gonna sign this. It's mutable. And a system program that I already speak with you about in a previous video or in beginning of this one, but anyway, system program I already speak about. And here we just imagine that we assign this all this stuff. We have public struct in syntax of Rust, where we have our public result. In our case, it's only variable that we have in the unit 64. And the unit 64, it means we can have straight to 64 bit of code for our spin. And our result, it's a lot of numbers. So anyway, we good here. So I guess we good now. Jeez, I don't know why, but it's really frustrating to try to explain this Solana stuff. Anyway, you can ask me in a commentary or in description. I will explain it better for you, because I am almost sure you're gonna have some issue or something to ask about with this. But for us, it's just one of the video of the Koma chain cycle where we speak about all chains, and for us it's just some simple demo here. You can find all code and readme file in the description. I will attach links to open source code. You can deploy it yourself or use my playground to check how it's work. It's work by my public key, by my private key for now. And you can try to connect and check if it's gonna work. But with this smart contract, it should be correct anyway. So yeah, if you want more Solana theory, you can ask, because it's all explained too fast for people who don't understand Solana at all, like blah 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 blah. But because we do review of project, we not have fully Solana theory here, because it's more about projects. But anyway, I try to explain some Solana stuff for you if you novice here. I'm not my job is not on Solana, it's on EVM chains, but still I read some docs about Solana, and even with docs it's a bit hard to imagine all this abstraction. In the first video I explain you this 3 wallets way abstraction for your token or smart contract, etc. And in first video I explain a bit, I show in docs and I explain it, but anyway, in this video we also can check how smart contracts work, how you can do the smart contract, and let's go.